Channel agents, saline, cathartic. Some of the important examples are sodium potassium tartrate and also the magnesium sulfate. Now I am going to explain some important points related to the sodium potassium tartrate. Okay, so here the molecular weight of this sodium potassium tartrate is 282.2. Okay, so molecular formula for this is CHOH COONA bond with that CHOH COOK. Okay, with 4 molecules of water. So that is the sodium potassium tartrate, and this is also called as the Rochet or Rochelle salt. Okay, so synonym for the sodium potassium tartrate is nothing but Rochelle salt. The procedure for the preparation of this sodium potassium tartrate. So this sodium potassium tartrate is obtained by neutralizing a solution of sodium carbonate. Okay, so Na2CO3 with that of the potassium bitartrate. So that is nothing but KHC4H4 and also O6. So here it is obtained by neutralizing the solution of sodium carbonate with that of the potassium bitartrate. So here 2 molecule of the KHC4H4O6 get react with the sodium carbonate where water 6 molecules will be there. So finally there is a formation of KNaC4H4O6 with 4 molecules of water. So that is nothing but sodium potassium tartrate with 6 molecules of carbon dioxide will be get liberated as it is. Okay, so the solution is boiled for some time and then allowed to stand at 60 degrees centigrade for the completion of the reaction. Okay, so at the 60 degrees centigrade only the reaction will get completed and neutrality adjusted and carbon dioxide is so slowly evolved. The solution is finally filtered and concentrated to crystallization. So that crystal formations will be the sodium potassium tartrate. Okay, so these the white crystals are the powder with the saline taste, and these are water soluble but insoluble in the alcohol. The salt effervescence. Okay, in the warm dry air. Okay, so sodium potassium tartrate salt shows the effervescence, so efflorescence in the warm dry air. So loss of this molecule will be water molecule will be takes place in this efflorescence process. Okay, what are the important uses, therapeutic uses of the sodium potassium tartrate? Is given in the solution form for its saline cathartic action. Okay, so and also used as a food additive, and so laxative effect, that is mainly forces are passed without gripping the purgative or the catharsis. Okay, so loose watery feces passed with the gripping and also abdominal pain will be there. Okay, so all these points are related to the sodium potassium and tartrate. And the another important example for the saline cathartic is magnesium sulfate. So here molecular formula for this magnesium sulfate is MgSO4 with 7 molecule of water H2O. Molecular weight for this is 246.5. So another name, synonym is Epsom salt. Okay, so preparation here this will be takes two method. What are those means? The magnesium sulfate is obtained by the action of the dilute sulfuric acid H2SO4 on the magnesium carbonate MgCO3 or magnesium oxide. Okay, or from the native carbonate. So here the magnesium carbonate and also the dilute sulfuric acid. So MgCO3 react with that of the H2SO4. This H2SO4 will shows the action on the MgCO3. Finally it forms the MgSO4, water and also carbon dioxide will be evaporated. The solution is filtered, the filtrate is evaporated to the crystallization. And another one is it is manufactured by the action of the sulfuric acid on the native carbonate magnesite, okay, or on the previously calcined dolomite. When dolomite is used, magnesium sulfate passes into the solution and sparingly soluble calcium sulfate gets deposited. So here the dolomite nothing but magnesium carbonate with calcium carbonate. Okay, so MgCO3 CaCO3 plus 2 molecules of the sulfuric acid. So action of the sulfuric acid on the native carbonate nothing but magnesite, or it may also shows the dolomite. Okay, so finally it forms the calcium sulfate with the liberation of the magnesium sulfate. Okay, the liquid is filtered and then the filtrate is evaporated to crystallization. Actually this magnesium sulfate occurs as a colorless crystals having a cool saline and bitter taste, but it is soluble in water, sparingly soluble in alcohol. So what is the important mechanism of action of this drug? Okay, so it is not absorbed from the intestinal tract and thus retain the sufficient water within the lumen. The hydrostatic pressure promotes the motor activity. So osmotic pressure will be there. Hydrostatic pressure promotes the motor activity or the peristalsis of the bowel, and usual dose of this magnesium sulfate is 10 to 15 gram, and it should be used with a care in patients with impaired renal function. Okay, if the patient is suffering from any renal disorder or renal function impaired, that time it should be used with a very careful terms. Okay, the important therapeutic use of this magnesium sulfate is actually given orally in a dilute solution. About 5 gram produces the laxative effect because of bitter and nauseating taste. Okay, just feeling like a vomiting taste. It is given in the fruit juices. Okay, so these two are the sodium, potassium tartrate and magnesium sulfate are the important examples for the saline cathartics, which comes under gastrointestinal agents. So with all these acidifiers, nothing but acidifying agents, antacids and also the protectives and adsorbents, and the last main group is saline cathartics. So with examples also we studied. So with this gastrointestinal agents main chapter will get over.